So students, up to lecture number 8, we have gone through direct stresses. That means when forces are applied directly, and those direct stresses were generally due to the forces which are normal forces. So that means the force is acting on a plane in a direction normal to the surface of the plane. So now in lecture number 9, we will be going to understand principal stresses and principal planes. So principal stresses and principal planes. Now let us understand. In practical engineering structures, that means the structures which we have built and they are subjected to forces or stresses acting on them are not always in a direction normal to the surface of the body, but they may act on inclined planes also. That means in such a situation, the resultant stress may or may not be normal to the plane at any section. That means whenever there is a body or there is an element and some force is acting on it, in general we have gone through that forces are normal to the surface. That means line of action of the force is at an angle 90 degree to the plane which we are just evaluating. That means how much forces are acting, and based on that we were able to calculate or evaluate the stress, and that stress was ratio of that force which is acting normal to the surface divided by area of that surface. That means till the lecture number 8 we have gone through the force or stress which is acting at a normal to the plane, as well as we have gone through the concept of shear stress. That means when there is some shear forces acting, and based on that shear stresses may develop, and that shear stress was given by the ratio of force divided by area, and that force must act as tangential to the surface. Now if you go through the most of the cases, direct and shear forces act simultaneously on a body, and the resultant stress we have to evaluate on the plane other than the normal plane. So these are the practical cases where these type of forces we have to evaluate the effect of these forces. Now in general, there are three mutually perpendicular planes carrying three direct stresses at any point in a material which is subject to direct stresses, and out of these three stresses, definitely one will be having maximum magnitude, other will be minimum, and third one will be intermediate between these two. That means there will be maximum stress and minimum stress, and third one the stress in between these maximum and minimum value. Now we have to understand a new concept, that is what is a principal plane. Now what are the principal planes? If you go through any structure or any body, then through that body if you select an element, then there will be infinite number of planes which may pass through that element. And what we are concerned, that means we will be concerned about three mutually perpendicular planes and how the forces are acting on these planes, how are the stresses acting on these planes. Now what is principal plane? The planes which have no shear stress. That means if you locate some particular planes in the body where no shear stresses are acting, they are known as principal planes. That means the direct stresses can act on them, direct stresses in the form of normal stress as well as tangential stress. But if there is no shear stress, then we will say that those planes are principal planes. It means principal plane don't have any shear stress value, but normal stresses, and these normal stresses on these normal planes are called principal stresses. So what we are able to understand in the definition part, that means principal planes are those planes on which no shear stress will be there, and on these planes there will be maximum stresses, normal stresses, and these normal stresses which act on principal planes are called as principal stresses. Now let us try to understand through these diagrams. Now let us suppose this is a body. It may be a rectangular body or square body, any type of body, and some force is acting on it. Now if you see here, now this force, this will be the line of action of the force. That means this force is acting at a normal to the plane of the body. So it is a direct stress, a direct force, and correspondingly there will be direct stress will develop. Now if we take some element in between the body, so this element will be subjected to the stresses in the direction of line of action of the forces which are acting on the body. Now here what we have to understand carefully, that means this force, if this force, let it is P, or it may be a stress and it is acting along x direction, so then this element will be subjected to direct stress along x-axis, and there will be no stress in this vertical direction, that means along y direction. So that means if one force is acting in x direction, that means this force is acting in this direction, x direction, then stresses developed in the element of the body, or you can say in the body, will be direct stresses in the same direction in which forces or stresses are applicable. Now here in figure number B, you can see here, that means now the stress is acting in the y direction. So this element will be strained along the y direction. That means stresses on the element will be also along the y direction, and there will be no horizontal stress developed in the element. Now case number 3, if you see here, the body is same body and we are applying force or stress in the horizontal direction, but the element which you are considering, that means element on which you want to find the stresses, that element is not in the direction of the force, but it has some angle of inclination to the force which is applied on the body. So this plane will be known as inclined plane or oblique plane. Now if you see, force is horizontal, but element dimensions or element sides are not horizontal. So that means we have to resolve this force in a direction normal to the element, surface of element. That means if black line is indicating a plane, so if we want to find out the effect of the force P, this force P which is shown here, let me make it clear. Now yes, now this is P force which is acting. That means this force is acting in the horizontal direction, or you can say along the x-axis direction, but the plane under observation is an oblique plane, not in either in horizontal direction, that means either in x direction nor in y direction. It has some angle of inclination along the horizontal direction. Now this element will be subjected to forces parallel to the plane, that means in a direction parallel to the plane as well as normal to the plane. So let us visualize this element as a bigger size, taking as a bigger size. Now P is the force which is acting in x direction, and then one component of the force will be normal to the plane under observation, that will be the normal force, and other force which will be acting, that means component of the P along the surface, that will be tau, that means it will be the shear force, and if we are taking tau then it will be shear stress, or otherwise you can write it as PT. PT means force in tangential direction. So this force P we have resolved into two directions. One is perpendicular to the surface of the element, other is parallel to the surface of the element. So parallel to the surface component will be PT, that is tangential force, and Pn will be called as normal force. So if this Pn is normal force, then if we divide it by area, then it will be normal stress, and Pt divided by area will be shear stress or tangential stress. So this is the difference between these three figures, and these forces may not always normal to the surface. If this force is inclined to the surface, then we have to understand and evaluate what will be the stress components along the plane which may not be normal to the surface. Now, method of analysis of stresses on an inclined plane in a body. There are two methods basically. One method is analytical method. That means we will analyze and we will be using some formulas to evaluate whatever is required. And another one is graphical method, that is Mohr circle method, which we later on we will be going through. Now some sign convention we have to use in analytical method. So very first sign convention is all the tensile stresses and strains are taken as positive, and compressive stresses and strains are taken as negative. Second is shear stress, which tend to rotate the element in clockwise direction, are taken positive, otherwise they are taken as negative. Now if you see here, this is an element and shear force is acting on the surface. Now this component, this 1 and 2, so what they are, they combinedly they will try to rotate into anti-clockwise direction. So this shear stress will be taken as negative, and the shear stress on the vertical direction, they have the tendency to rotate the body in the clockwise direction, so it will be taken as positive. So this will be the way how to decide the sign convention before using the analytical method. So stresses on an oblique section of a body subjected to direct stresses. First of all, direct stress acting in one plane. So here let us take a body or an element. Sigma is the stress which is acting along x direction, and what we have to find out? We have to find out stresses which are developed on a plane AB at an angle theta with the line of action of the force. That means sigma which is acting that as a direct stress. So this direct stress is acting along the x direction, and the plane on which we have to find out the effect of these direct stresses, that will be having an angle of inclination. It may be theta with the direction of line of action of the stress. So here let us consider this body, rectangular body. This body have uniform cross section area throughout the length A and unit thickness. So that means in other direction thickness of this body will be 1 unity subjected to direct stress along x-axis. So AB is an oblique plane. Oblique means inclined inclination with the direction of the force or stress. So AB is an oblique plane on which stresses we have to evaluate. So now from this figure you are able to see that AB is an inclined plane and AC is the vertical side which is normal to the direction of the stress. So as the stress is acting in the along the x direction, so force due to this stress acting on the face AC and this force can be calculated by stress into area. Now P is the force which is acting along the x direction on the face AC. Sigma is the stress into area of the size. Area of that side, that means AC. AC is the size of the element and unit thickness. So area of this AC element will be AC into 1. Now this sigma is acting, so we have taken this wedge ABC into consideration to find out the stresses acting on AB plane. Now theta is the angle of inclination. So sigma is the stress acting on face AC, or ultimately we have to divide this stress in two planes. One is normal to the plane AB and other is along the plane AB. So this normal direction will be normal to the plane and other side will be tangential to the plane. So what we have to do, we have to resolve this P force due to this direct stress into two components, in two direction, normal and parallel to the plane AB. So this will be given by formula Pn is equal to P sin theta, and P value we have put here sigma AC into sin theta. So this will be equation number A. And similarly in this direction, that is in the tangential direction to the plane, that PT will be the force in tangential direction will be given by P cos theta, and P is sigma into AC into cos theta, so it will become the equation B. Correspondingly, we can find out normal stress as well as tangential stress. So normal stress sigma n, this is normal stress sigma n. Sigma n will be Pn divided by area. So Pn is P sin theta. So P sin theta divided by area of a plane AB. Now area of plane AB will be length of plane AB into unit thickness. So P sin theta value we have taken from equation number A. It will be sigma AC sin theta divided by length of this plane AB. So AC divided by AB into sin theta. Now what we observe here, from this triangle which we have taken into consideration and putting the values, we will get sigma n is equal to sigma, this is also AC by AB is sin theta, so it will be sin square theta. So sigma n, that is normal stress to plane AB, will be sigma sin square theta, and by putting the formula from the trigonometry, so we get the value of sigma n is equal to sigma by 2 into 1 minus cos 2 theta, where sigma n is stress normal to plane AB, sigma is the stress which is applicable perpendicular to side AC. So this will be the normal stress given by sigma 2 into 1 minus cos 2 theta. And similarly, in the tangential direction, we are able to calculate tangential stress, that is given by sigma by 2 sin 2 theta. Here we have just take the help of trigonometric formulas. So ultimately we can find out the resultant stress. So resultant stress will be given by sigma r, that is sigma n square plus tau square. So that means sigma is acting in a as a normal stress, and when you have some angle of inclination, that means there is a plane which is making an angle of theta with the direction of the the direction of the direct stress. So that means you have to find out these two stresses and correspondingly resultant stress we have to calculate. Now stresses on an oblique section of a body subjected to direct stress in two mutually perpendicular directions. Now from this figure it is very much clear. One is sigma x, other is sigma y. Sigma x is direct stress along x direction. Sigma y is direct stress along y direction. And again, we have to find out the effect of these two stresses on a plane AB which is at an angle theta along the x direction. So accordingly we have to find out. Now sigma x is acting normal to AC, sigma y is acting normal to CV, and AB will be the plane under observation. So it will have again two directions. One is normal to plane, other is tangential to plane. And normal to plane, what will be the stress due to these two sigma x and sigma y, that is sigma n, and the stress which is acting parallel to the surface of the plane under consideration, that is AB, tangential to the plane, that is tau. So again, similar to the previous case, force along x-axis acting on face AC. Now it is given by Px is equal to sigma x into AC. Similarly, force along y-axis which is acting on face BC is given by Py is equal to sigma y into BC. Now resolving these two forces into two directions, one is normal to the plane AB and another is parallel to the plane AB. So what we will get? Now Pn is the force normal to plane AB due to these two stresses sigma x and sigma y, and when we resolve these sigma x and sigma y in a direction which is normal to AB, then we will get this formula Px sin theta plus Py cos theta, and Px we get sigma x AC into sin theta, and also Py will be sigma y, it is acting on BC into cos theta. So it will give equation A. Now this equation is giving the formula to evaluate force which is acting normal to a plane AB, which is an oblique plane having an angle theta with the x-axis. And similarly, PT will be the force which is acting along the plane, that means tangential to the plane AB, that is given by Px cos theta minus Py sin theta. When you resolve these forces, then you will get this equation. So it is sigma x AC cos theta minus sigma y BC sin theta. So these equation A and B will give the value of normal force as well as tangential force, and these normal force and tangential force which are acting on plane AB due to sigma x and sigma y, which are two mutually perpendicular direct stresses. So hence normal stress accordingly sigma n, that will be normal force divided by area AB into 1, and after solving the trigonometric formula, what we will get ultimately, sigma n is equal to sigma x plus sigma y by 2 minus sigma x minus sigma y by 2 into cos 2 theta. So this equation is the equation for stress in a direction normal to the plane AB which is under consideration. Similarly, solving equation B, we get tau is equal to sigma x minus sigma y by 2 into sine 2 theta. Now let us have some discussion on these two cases. First one was direct stress in one plane. That is the figure which we have already discussed. That means now let us revise it. This is a body which is subjected to sigma, that is direct stress along one plane, and what we have to evaluate the effect of this stress on a plane which is having some angle of inclination theta with the direction of the application of the stress. So from this we are able to get these two formulas, sigma and normal. That means stress in the normal to the plane AB, and tau is stress which is parallel to the plane AB in the tangential direction. Now we have to here evaluate, that means when sigma n will be maximum or when tau will be maximum. So normal stress sigma n, when it will be maximum. So to make it maximum value or to get maximum value, this cos 2 theta will be equal to 0. So when cos 2 theta is equal to 0, that means this angle should be 90 degree and accordingly theta will be 45 degree. So that means when this plane is having angle 45 degree, then on this particular plane your sigma n, that means normal stress will be maximum, and that normal stress maximum will be sigma by 2, because this will be 0 and 1 minus 0 is equal to 1, and correspondingly when we put the value theta 45 here, then sine 90 will be 1, so tau will be sigma by 2. So similarly we can evaluate sigma n and tau for different type of planes having different angle of inclination. Now when direct stresses are acting in two mutually perpendicular direction, then we got these two formula. Now again we have to find out where this tau will be maximum. Now this tau will be maximum when sine 2 theta is maximum. So to check the plane where shear stress is maximum, so sine 2 theta is equal to 1, then theta is equal to 45. So tau maximum will be sigma x minus sigma y by 2. It shows that in a body under stresses in two mutually perpendicular direction, shear stress will be maximum at a plane at an angle of inclination 45 degree. So later on, when you go through the other courses like design of concrete structures, so you will get the application of these principal stresses in those cases. So one thing is very much clear in B case, that means when an element is subjected to two mutually perpendicular direction, then the plane which is having angle of inclination of 45 degree, on that plane your shear stress will be maximum. Thank you.